So there are many variants of buffer overflows, but I'm going to give a real-time scenario, real-time sort of context of the one we're about to do, and you know when it can be used in the real world. So the one we're about to do sort of operates like this. It's, you know, you're an attacker. You know, you're on a network, and you've got access to a victim machine, but you've only got access to a victim machine as a guest or a, so let's just say, normal user. That's not a very good body drawing, is it? Let's go back. You're a guest or a normal user, and you obviously want to get admin, but this machine has a 32-bit vulnerable binary that it's running on a port. Now, you've noticed this and you think that's a good way I can get admin, I can exploit that. So you copy the binary onto your own VM with Immunity Debugger on. Now, in this video, Immunity Debugger is actually on the victim machine for ease of use for learning purposes, but you would actually have to run Immunity Debugger as an administrator to do this exploit, so that's why you'd need to have it on your own machine. So once you've got Immunity Debugger on your own machine and you've got the binary on there, you can overflow it to loop round into msfvenom shellcode that'll do a reverse shell and get you an admin shell on the victim machine with the binary running on a specific port of the network that you're on. That's essentially a quick use case. There you go. Okay, here we are. Am I recording? Yes, I am. This is Tib3rius's Win10 victim machine. He's put Immunity Debugger on for ease of use, and he's put a bunch of vulnerable binaries for people to practice on. The one we're going to be doing is the one he mentions in the room here, which is the OSCP one, because it has 10 different variants. If I open it, it's a binary that runs on port 1337. If I netcat to this, you can see it's got 10 different values with 10 different ESPs and EIPs. It's really good for practicing. It gets across the rinse and repeat process that's required in the methodology of buffer overflows. The other binaries on the Win machine here are worth doing, in my opinion. It shows how it pans out differently. No pun intended there, Mr. Brain Pan. But yeah, it shows how it pans out a bit differently, and it's good to get different sort of angles and, you know, different sort of variants of buffer overflows, as well as just the single binary 10 variant one that we're about to do here. But yeah, without further ado, let's delve into it. As I mentioned earlier, you know, you need to run Immunity Debugger as an admin for this exploit. So we're going to run Immunity Debugger as an admin. Oh, 1 sec, let me just make sure that we've closed the process here. Yeah, we haven't. So you don't want to make sure it's running in the background. That's not good news. So now we've got rid of that. We can run this as an admin. Open the vulnerable binary that's in the folder here on this machine. We're going to run this. So now the binary is running. We're going to set our working directory with Mona here. This will be in the description with the other commands that are needed and my written methodology. I'm going to stick that on here. You can follow if you prefer following written things. So now the program's running. We can see on the Windows screen the CPU main thread. It's running here and Mona's been set. So now we're going to crash the program. So for a buffer overflow, you need 3 Python scripts. 1 to crash the program, 1 to exploit, that's going to change as we go, and 1 to find bad characters of the exploit. Obviously the first one we're going to start with is fuzzing. So I'll open this and show you what it's made of. Put the IP in of the victim machine. That's the port that the program runs on. The prefix that we're going to be exploiting is Overflow 2 today. Everyone seems to do Overflow 1 in this Tib3rius room video, so thought we'd just do 2 or start with 2 or whatever. And yeah, that's what it looks like. It goes in, sends 100 A's. So as you can see what it does there. So I'll drink some water real quick. Sends 100 A's, and yeah, let's run it. So if I run fuzzing.py, you can see this program's running. This program's about to crash at a certain point in bytes. Now with fuzzing, as you can see, it's just crashed there. With fuzzing, now the majority of fuzzing scripts, they run between 50 to 100 bytes ish, around that variant, because it's just a rough estimate. You don't want to really be any more than 100 bytes, I'd say, when you're fuzzing. But if I wanted to, I could easily change this to, you know, let's send 50 A's and go up in, you know, quantities of 50. So I'll do this just for example purposes. Oh, the program's already crashed, that's why it won't work. So I'll run this again. If I'm going up in variants of 50, it's going to crash. It's going to be crashing at 650, 700 or 750 here, I think, if it goes off what we've just done. Yeah, so we know that it's in the latter end of 700. So it's somewhere between 600 to 700 kind of bytes. That's where it's crashing. As I can say, as I've already said, it's a rough estimate. So you know, I prefer just to do variants of 100 because we have to add a padding variable of 400 anyway to this. So we've got 700 as the thing. That's what we're going to go with. What we had here. That's the way I have it in my methodology, and that's what I stick by. So I'll drink some more water, but. Once you've done that, you can create a pattern with msfvenom in your terminal, and this is 400 plus values what I've got written in it. 700 plus 400 padding, so that is 1100. Once you've got that, you've got your padding payload, which you can add into the exploit.py Python script, which I'll also put in the description in GitHub or whatever. And these scripts you can use template-ish for majority of buffs, I want to say. There's a lot of variables you need to change in here potentially, but you can kind of use these templates for majority of buffs. Again, I've got the IP, the port, the prefix, the offset should be 0. I don't know why it's not got any variable there at the moment. Payload, just going to launch that in there, save that, and now we're going to crash the program again. That's what buffer overflows are all about, right? Crashing the program. Well, hey, right, so we're going to go python 3 exploit.py. Boom, we've crashed it. Right, oh no, what's going to happen? I'll tell you what's going to happen. We're going to put a return variable of 4 B's in here because we want 42, 42, 42. We want to crash the program at that variable, right? And then the next thing we're going to be doing, as well as doing that, is finding the distance with Mona. Because we've crashed it here, we need to find the offset. And the way we do that is with this command. Boom. We can see we've crashed it. The EIP pointer offset crashes at 634. Now that variable is very important. I'm going to throw that in here, 634, boom, press save. And you know, once we've done this, we've got an offset variable and a return variable in our payload, and that's great because now we can crash the program, and it should crash at 42, 42, 42. So if I go python 3 exploit.py, boom, we can see the EIP register is 42, 42, 42, 42 because I've added 4 B's instead of 3. So that's just the way that's gone down. And yeah, so now what do we want to do? Well, we want to find the bad characters, but you know, how are we going to go about that? Well, we need to make a byte array. That's the first thing we need to do. Again, the Mona commands will be in the description. Mona byte array, boom, press this. It adds every single byte in an array that could potentially be added together in different combinations to make registers right in front of our eyes, ladies and gentlemen. Right there, boom, you've seen it, I've seen it. Now what do we need to do next? We need to run badchars.py to mimic the exact output that you can see right in front of your eyes here. So we need to go badchars.py, boom, what do we see? We see the exact same thing. We're going to go Control-Shift-V because I'm in a VM. We're going to paste this into the payload variable, right? So now we've got an offset, a return variable of B's, right? And we've got a payload variable. So what we're going to do is we're just going to constantly run the payload and compare the byte array with the ESP address, and then that will output bad characters which we will remove one by one until we have an unmodified final exploit script. Okay, so let's get started with this, guys. Let's go straight into this, right? We're gonna make a note of the ESP address after running this new exploit. So we're just gonna go File, Open, OSCP, Play, boom, run the exploit, make a note of the ESP address, right? So we've got the ESP here, copy selection. I'm just gonna comment it down here. Always easy to comment. You know, who doesn't like a good comment? We're going to copy this Mona command in here, A, and then we're just going to throw, boom, copy selection, boom, throw that in there, boom, Bob's your uncle. You've got your bad characters here, 23, 24, 3C, 3D. You can see that, I don't know if the word is adjacent, but they're next to each other, a lot of these characters, right? So, one thing you'll notice of bad characters is, if I was to remove 23, then 24 would probably disappear. Bytes overlap sometimes, right? Sometimes the byte arrays can overlap, and it's really, you're just removing one character, but it displays it as 2 in Mona, okay? So this is what we're going to do. First things first, open up our exploit. We're going to go with Control-F, and we're going to type in 23, right? Because we've got 23 there. I'm going to remove it, right? Get rid of that thing. I'm going to drink some water right now. 23 is gone. Yeah, so now we're going to open the script again. Well, we're going to open the vulnerable binary again, run it, and then we're going to run our exploit again, right? And what we're going to do now is copy that ESP address and paste it in there, press enter, right? What did I say to you before? If you remove 23, then 24 will probably disappear. What's happened? 24... it's gone, mate. It's not there anymore. You know, it's disappeared, right? So we're probably going to be seeing a 23, 3C, 83, BA kind of variables before I'm even... and that's what my guesstimate is for this, yeah? But for all intents and purposes, we're going to carry this out one by one anyway. So we're going to go 3C. Hopefully I've not just ruined that, but I don't think I have. Open the binary again. Run the binary again, run the exploit code again, open the CPU register, copy the ESP variable, paste it in here, press enter, boom, 3C, 3D was it, or 3C, 3B or something, boom, they both disappeared, mate, just by me entering one, just like that, right? Next thing, 83, yeah, 83, get rid of this bad boy, save this again, open, boom, run, play, boom, open the exploit, boom, run the exploit, open the register, copy the ESP variable, paste it in here, boom, what we seeing? Oh my god, 83, 84 was it? Something like that? Gone, mate. Next one's BA, yeah? Control F, BA, remove BA, yeah? Save, boom, open the binary, sorry, run this, open the, run this, run the exploit, I'm talking too fast, open this, register, ESP, copy selection, boom, oh my god, look at that. So now what do we want to do? We want to note down every bad character that we've removed, sir, so we're going to go, and we're going to write it like this, 83, BA, add the quotes, have a drink of water. Stay hydrated, folks. Why is this? Oh my god, it's doing that AIDS thing, bro. 0023 3C 83 and BA. Yeah, okay, cool. There are bad characters. Bang, bish, bash, bosh, right? So once we've done this, we want to compare we want to add the byte array with our final char. So now we're saying to Mona, hey, here is a definitive list of the bad characters. Can you compare it to the ESP for autos and see if it's correct? So we're going to go add these into here, right? That's not correct, and that is probably because there's no X there. Yeah, right, boom, there we go. Right, so now we've added a new byte array, we've updated it, we've removed the bad characters of this argument. It's all good. Saul good, man. Like Saul Goodman, you know? Better call Saul. So now we're going to run the compare command again, yeah? So we're just going to run the program as we add it. Run the exploit as we add it. Boom. CPU registers. Open this, and what do we see, right? We see an ESP variable. We want to compare this again. In my opinion, I think this is what we need to do now. We need to just literally do this and compare it to this, and it should compare it to the byte array we just made, and we see unmodified as the status, right? This is really important. That means we've removed all of the bad characters that are in the exploit that we're making. So now we're going to find the jump ESP address, right? So we're going to type this in. We're going to get our bad characters from before. Remember that X that we didn't have? Yeah, we need to add it in there, but it's being annoying, but we've done it anyway. Right, we need to copy this, throw it in there, press enter, right? Boom. We should see, not on the CPU window, we should see another window here with jump ESP addresses somewhere in my many windows of Windows. Here it is, it's in the log data window, right? Now, with jump ESP addresses, sorry, maybe it's easier to see. Bloody hell, what have I done there? Community debugger, come back. Come back, community debugger. We've got false, 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 and false for ASLR, rebase, safe SEH, and OS, right? That's what you want. Just because it's false on everything, we can pretty much use any of these addresses, right? These registers, right? The thing is, a lot of buffer overflows will have false, false, true, false, but this one in particular doesn't, so we can use any of these. You want to look for the one that has all falses, moral of the story. Copy the address, right? And for our return address, this is what we're going to do now, right? We're going to comment this, right? And then we're going to backwards. Oh, for God's sake! This thing. Sorry. This is really doing my head in now, the way it's getting rid of my my previous things. I'm hoping this will be enough room. X11, X50, X62. Is there a bloody... Oh, it's quotes. Right, so that, ladies and gentlemen, should be correct. And we're just going to add a bit of a padding variable in here as well. Right, so we're just going to add 90 times 10 as... times 10. As that, and then we're ready. Well, we'll add 16 just to make sure we're okay, and then we're ready to run our msfvenom payload and catch a shell, right? So what we're going to do now is we're going to run a command like this, right? It's one of the msfvenom commands. It's a reverse shell command. It's on 0. Let's change the port here because I had issues last time. And we're just going to put the bad characters from the exploit script that we've commented out in the bottom here, right? And yeah, boom. Once we've done this, we can run it, and we just want to generate our payload here. Actually, just so this doesn't error out. Because I had problems with ton0 being a variable last time as well. I'm just going to type my localhost LPORT manually, right? Generate our payload. Drink some water, stay hydrated. check my recording still on. Yes, it is. Thank God. Copy the quotes. Well, the payload. Chuck it in the payload section. Oh my God, it's not good for me. It's horrendous. And we now need to do this. Oh no, I had a feeling that would have happened. And then we need to, boom, do that, yeah, right. That's looking good to me, yeah. That is looking very good to me. Right, and now, all we need to do is, we need to listen to, are we listening or are we connecting again? Let me have a wee little think. We need to listen to port that we've put in the payload. And what was that again? Was it 4444? I think it was, right? Yeah, 444. So we're going to listen to 444. Our exploit saved. We're going to run. We're going to play. We're going to run the exploit, sorry. Had a bit of a moment then. Python3 exploit. And who am I? Didn't catch it, right? Why didn't we catch it? Probably because of the syntax in here. Maybe I need to put brackets in. Oh no, that's annoying. Bloody thing with me cursors doing me head in. NVLP. Run this. Let's run in. Listening. Exploiting. Boom. Who am I? Admin. Right. A little syntax error at the end. It's no danger for the dovey boy, yeah? We can get around that. No problems, mate. Hope everyone enjoyed that little video. I'm an admin on here. I know I've tried to record this a couple of times. My headset died halfway through the first time. So I was going to do some more, but I think we'll just leave it as that. Little brief overview of the one of the buffer overflows from Tib3rius' room. I'll put the methodology in the chat. GitHub link, you know, yada yada, all that jazz. And yeah, yeah, hopefully that'll do for my first video. Farewell and goodbye.